Okay, so in this chapter we will briefly visit the ideas, issues, research on communication and dissemination of forecasts and engaging user communities. I may have mentioned this already, but there is plenty of research now where the old ideas of just putting up forecasts on the web or issuing forecast bulletins, letting users determine for themselves how useful it is or how they will use it. Now much more research and the engagement of users even during the production of the system to design the best way to display the forecasts and the language to be used and so on are done. This is called co-production, because the usability and the use of forecasts goes up by a lot when the forecast and the dissemination communication systems are co-developed with the users from the beginning with their engagement and sustained feedbacks. This is a simplified schematic of a meteorological hydrological service information value chain from a report from the WMO, which aims to model the value of information through weather and climate service production and delivery systems. Value, which is typically described in economic terms, can be added or lost at each step in this non-linear process. So you are going from the forecast here with value-adding processes and communication processes. There is service production, basic and specialized services, sector-specific, for example, food, water, energy, health, and so on. The national meteorological and hydrological services and commercial providers. So there is lots of players now in this space, with which of course was always there in the weather space in Europe and US, but now even in the S2S space, and also for climate services, which is now growing more and more in terms of a framework under WMO. Of course it was there informally as El Niño forecasts and its applications to fisheries, agriculture, health, and so on. User decisions and actions to outcomes, and then there is a feedback from the forecast to make sure outcomes are as desired, so that value in terms of benefits and costs are realized, maximized, optimized, whatever. This is an example of seasonal forecasts, and this is probabilistic forecasting, where the Canadian Service Environment Canada offers temperatures here as below normal probabilities, near normal, and above normal probabilities, so that instead of actual temperatures, you give users a way to decide for themselves based on their own knowledge of what is normal and below normal. They can decide how good or how bad it is in terms of what they have to do. For example, planning the weekend, what to wear when you go out, planning for driving, storing food, whatever, right? This is from NOAA NCEP, which is showing precipitation. Both of these are S2S timescales. So this is March, April, May 2017 forecast issued on February 28, 2017. This is March, April, May, June, forecast issued on March 16th, 2017. So very much in our focus of S2S forecasts. So this is again showing normal, above normal, below normal precipitation. So this is probabilistic information that farmers can interpret themselves. Most advances in communicating with the users and dissemination of forecasts and the dashboards that users can use have come from Bureau of Meteorology, Australia. So this is not very readable, but I will just mention this is the National Rainfall Outlook issued on February 24th, February 2014, and you can see that there is a summary here, and it's captioned drier autumn more likely for parts of Queensland, while weather favored in the west. And then there are details and climate influences included, schematics that can be used by schools, teachers, users, and of course there is a more detailed dashboard where people can choose various quantities, storms, rain, maybe even for energy, solar energy, waves, and so on. So you can see how many options are given. It can be downloaded, the interface, onto a laptop or even onto a smartphone, so users can use them as and when they want. There is a constant feedback process in place as well, and what they do is issue multiple forms of communications. An at-a-glance summary of the rainfall and temperature outlooks is issued. Ability for users to tailor the forecast to their location and critical thresholds, for example, pop-up boxes of location, span and zoom maps, user-selected probabilities, and rainfall thresholds for their own region can be chosen. Better provision of model accuracy information. We talked about uncertainty depictions before. Easier to understand language, better color schemes supporting educational material. So awareness goes up continuously, and the demand for information goes up with that as well, which is okay. Short monthly video with a climatologist explaining the outlook and putting information in the context of recent conditions and current climate drivers. Supporting explanatory information about the service and educational material, including videos and infographics about the major climate drivers. Okay, so I will read this in the next podcast, but let's leave this here. But you get a sense that S2S forecast now is getting better in terms of process understanding, MJOs, MESOs, El Nino modulation of these of these timescales, weather regimes that are produced because of that, or higher latitude tropospheric stratospheric interaction processes that we talked about, QBO modulation of MJOs, blocking patterns, NAO at subseasonal timescale, and so on. But now we are talking about taking the skill and communicating and disseminating the information along with the probabilistic information and uncertainties, and how to constantly engage users to make this whole package better. And when private companies get involved in any of these forecast businesses, we will see some examples in the next podcast. They are keenly aware of what people will pay for. So agencies like Environment Canada or NOAA, they don't necessarily cater directly to private companies. So private companies use NOAA and Environment Canada forecasts to derive products, add values, and provide very local specific, region specific information. Some of them invest in their own observational systems and so on, but nonetheless the public-private enterprise seems to work well in countries in Europe and in the US. India is getting private players now in various sectors at weather and S2S timescales, so this has to be watched as to how well they will begin to serve the users and whether they will survive by making money on their products. Okay, so it does help because the private companies may be better at engaging users and being more in tune with their demands, because private companies need everybody to pay a rupee for the information they want. So that makes it much more of a focused effort as opposed to national scale focus of the agencies, hydrological, meteorological agencies. Okay, just a general point, but I think you understand what I'm trying to say.